Hi everyone. Today we're going to go over two sections of notes. The good news is both sections have to do with one another, so we've combined them for Unit 4. The first section we have to just graph a single line, and then for the second section today we'll be graphing two lines at a time. All right. So if you look at the title of this first page, we have 4.4 linear inequalities. And we have seen linear inequalities before. Those had to deal with our less than, our greater than, our less than or equal to, or our greater than or equal to signs. All right. So again, we're talking about those inequalities. Remember when we introduced them prior in the semester, we talked about, for example, a roller coaster ride. Well, if you have to be 5 feet tall to get on a ride, you can't be less than 5 feet. You can only be greater than or equal to 5 feet tall to get on the ride. If you go into a classroom, for example, and the capacity for that classroom is maybe 60 people max, well, you can't go over 60, so you have to stay under. You have to stay less than 60 people, and of course, you can still equal 60 people in that room. So then we're going to be talking about inequalities some more today. However, we're going to be talking about linear inequalities. So we're talking about lines this time, but the same rules are going to apply when we talk about inequalities. So to get started, we have our graphing method here. And so we can graph the method, we know how. That method is going to be slope-intercept form. We know how to graph slope-intercept form. So we want to make sure that it is always in y equals mx plus b form every single time. And then when we create our line, because we're talking about inequalities, remember, it can be less than, greater than, less than or equal to, or greater than or equal to. And if you remember when we did those compound inequalities before, we talked about open and closed circles. That's going to be the same concept today, but we're going to have what's called dashed and solid lines. Same thing, whenever we had an open circle, in this case today, we're going to be talking about dashed lines. But whenever we have a closed circle, we're going to be talking about solid lines. But it's the same rules. You'll notice that whenever it's dashed, there's no equal signs. But whenever it's solid, there will be an equal sign. So that is one key detail we're going to have to keep in mind as we go through. All right. And then lastly, we have to deal with shading. So if you happen to look at example 3, you'll notice all that red right there. That is considered shading because it's everything that includes everything below that line. It's not just the line, it's everything below that line as well. That's how inequalities work. If I go back to that scenario when I said we can have 60 people in a classroom, well, that's not just 60 people, it's anything less than 60. So even one person in the room is allowed, or 2 or 3 or 4, all the way up to 60. There's a lot of endless possibilities. All right, that's why we're going to talk about shading today. And so I have this rule here that says when we go to shade, we're going to test the coordinate 0, 0. And if it works, we're going to shade towards 0, 0. And if it doesn't work, we're going to shade away from 0, 0. All right? That's going to be a method that you can fall back on if you don't remember how to shade, if we don't remember if it's above or below the line. But I'm going to try to show it and explain it in a way that will make sense so you won't have to necessarily test a point. But we can go over that if needed as well. All right, so let's jump into some equations and get started. So for question 1, it's asking us to graph the linear inequality, y is less than negative 3x plus 5. All right, the only difference in today's notes is we have inequalities instead of equal signs, but the same rules are going to apply. If I were to write on top and say y equals mx plus b, I'm going to match my parts. So m is going to be negative 3, and my b has to be 5. As soon as I know this information, I know that I have the coordinate 0, 5 that I can plot, and my slope is telling me that I'm going to go down 3, right 1. Remember, when in doubt, graph it out. We need to know how to make our graphs. Now, before I connect my dots this time, take a look at the inequality. Am I going to include everything on that line if it's just a less than? No, I'm not, because it's only a less than. There's no equal sign. So I need to remind myself that when I connect my dots, I need to have a dashed line. So you can either choose to have a straight line and then go in with your eraser, that's fine, or we can just eyeball some dashes throughout the entire line. Okay. That's how we do the line. Now we have to do the second part, the shading part. Well, we have to figure out, is it everything less than that line or everything above that line? Less than is everything below, above is everything greater. All right, we'll go back to the original. It said y is less than -3. And think about your values on y really quickly. So I'm going to go in here in green for just a second. Actually, I'm going to go in yellow. Along this y-axis, let's say up here, all my y values above that line are going to be bigger. And so it's going to be greater than instead of less than. But if I go in green here to everything below that line in regards to my y, that's going to be everything less than y, which is what I wanted. That's what the inequality is asking for, is everything less than y. So I get to go in with my pencil, and I'm going to shade this entire piece. All right. Now, is this a coloring game where we have to make sure that it's perfectly shaded till the end of time before everything, you can't even see anything at all? No. All right. If you want to go in and just do a quick sketch like this with your pencil, that is perfectly fine. All right. We just practicing shading. That's telling me that, hey, this line works, but it's also this line as well as everything below that line that's going to work. Any one of these coordinates, if I were to test them, any one of these coordinates is going to work. It's going to make this statement true in the equation that I had. If I plugged in -1, 3, -1 for x and 3 for y, it's going to come out true. That's how we know which side is going to get shaded. That's how testing 0, 0 would work. You would test this point right at the origin by plugging in a 0 for y and a 0 for x. That would give us 0 is less than 5. Well, that is a true statement. 0 is indeed less than 5. Therefore, I want to shade towards that 0, 0 that I just marked. That's how that testing is going to work. If you can't remember if it less than is below the line, greater than is above the line, just remember you can always test 0, 0. All right. Let's try question 2. So right off the bat, let's identify the form. It is still in slope-intercept form. But we have to keep in mind that the number in front of that x this time is actually a 1. It's not a 0, it's a 1. And at the same time, since we're looking here, I have an equal sign. So think about the type of line that we're going to have when it's an equal sign. And it's going to be a solid line. Now we can go and start our picture. So my slope is 1. My b this time is -2. So that's going to tell me the coordinate 0, -2. And my slope's going to tell me I need to go up 1 and right 1. So I start at 0, -2, up 1, right 1. Continue that pattern. Get as many points on your graph as possible. I can also go the other direction, keeping that pattern going. And this time when I connect my dots, I get to use a solid line. Again, because it had an equal sign. I have my line, but inequalities are different because I have to also shade. And this time it's telling me I want to shade everything greater than that line. So take a look. Everything greater than that line is either going to be above the line or below the line. Think about greater. Greater means above. It's another word kind of makes you think of above. So when I go to shade, I'm going to shade everything above this line. And I know that if I tested any of the points that are in this shaded area, any of them at all, I know it's going to work out. It's going to come out true. But if I tested this coordinate over here, let's say that's what, 5, -4. If I test that coordinate there, plug in a -4 for your y, greater than or equal to 5 minus 2, and I were to solve this out, it's going to tell me that -4 is greater than or equal to 3. Is that true or is that false? That's a big fat false. Therefore, this point is not included. That's why I'm shading the side above. Shading means it's included. Every single one of those points that's in the shaded area will be included. Anything not will not be included. All right. So now that we've practiced graphing, let's try one that's already graphed for us. We're going to work backwards this time. All right. This time it's asking me for the inequality. Well, think about the functions we've seen in the past. We've seen y equals mx plus b. All right. But today we're not talking about equals. We have to talk about inequalities. So I'm going to take that equals out, and I have to fill that in depending on the graph that I'm looking at. But I am able to see my slope, and I am able to see my b based off of this picture. So let's start with our slope. So we look at a point that we see pretty nicely on my graph. You can look at your paper. All right, it's touching all 4 corners of those squares, so I know that's a good point to use. And my slope refers to my rise over run. So if I start at that point at the origin, and I go up 1 and over 3, it's going to run me into another perfect point. So my slope is going to be 1 over 3. Up signals a positive, and right signals another positive. So that's 1 over positive 3. I have my slope now. The only other thing I need is my b. Remember, your b runs all along the y-intercept here. So you're looking for the point that crosses the y-intercept. And if you look closely, that point is actually the same one we used earlier, and it's at the origin. So when we look and we ask ourselves what the b value is, it's actually going to be 0. Because think about what your y is at that coordinate. Your y is actually 0. Your x is also 0, but we're focused on just the y. So now if I have those 2 parts, I can put it in a slope-intercept form. So I'm going to say y. I'm leaving out the equals because I have to figure out what that is going to be. And I have 1/3 x plus 0. Of course, do we need to say plus 0 at the end there? No, if you leave it, that's fine, but we don't need to. Now I have to figure out what this missing piece is going to be here. All right, so we need to use the graph as a reference. We need to pay attention to one. First of all, the line that was showing, is it solid or dashed? All right, and if you look closely, you'll see that it's a dashed line. Therefore, my only options is a less than or a greater than. There's no equal to in this scenario either. All right. Once we know which one we're working with, we have to look at the shaded area. Well, is it everything above that line? Is it everything greater than the line? Or is it everything below the line and everything less than? And if you take a look at the shaded area, you will see it's everything below. So we want to give ourselves the less than symbol. And we have our inequality. That's all we needed. Use the graph. We can identify our slope and our intercept based off of the picture. And then use the line to determine if it's a equals to or just a less than or equal to, or a less than or greater than symbol. All right, let's try question 4. Question 4 we've kind of talked a few times about. All right, it's a little bit different of a picture than we're used to. This is if we had a hiker. Remember, if he's going up the hill, we have a positive slope. If our hiker is going down the hill, we have a negative slope. And if he's walking flat, meaning horizontally, we call that a 0 slope. Now, our hiker isn't doing any of that. If I drew in my hiker here, he's going to actually fall straight down. All right? And that is going to tell me that my slope, my m, doesn't exist. It's undefined, if you will. All right, so that doesn't mean that we're done. It just means that we're going to have a different kind of line. So think about the line that we see here. think about our x and y coordinates everywhere along this line. The only values that are changing, if I were to ask you for this coordinate here, you would tell me that it was -2, 5. And if I asked you for this coordinate here, you would tell me it's -2, 2. And if I asked for any other coordinates, you would always tell me your x value was what? It's always -2. So our x value is actually never changing. Therefore, that is the function that I have to use. My function this time, instead of it being in terms of y, actually has to be in terms of x. That's the only reason, because it's a vertical line. I know I'm talking about a function that's in terms of x. And the second part we need is, well, what x value is it always at? -2, so that's the second part. And of course, I want to make this into an inequality, so I need that piece that's in the middle. Well, we know it was a solid line that we were working with. So that automatically tells me that I need everything equal. I need to have that equal to sign. And then if I look at this vertical line, everything to the left of that line, if you follow your x values to the left, they're getting smaller. They're getting less than -2 as you go to the left for your x values. And if we go to the right, we would be getting bigger than -2. We'd be getting greater than -2. Well, if I want the inequality that goes with this graph and the way it's shaded, I know that this left-hand side is shading everything less than -2. So I want a less than and I want an equal to because it has a solid line. That is the only function I need to have for this example. Okay, vertical lines you will see every once in a while. It's not extremely common, but if you ever do see a vertical line, it's always going to be an x equals something. It's never going to be y. Vertical lines are just x's only because your x values are never changing. All right. So let's head into page 2 here. And we're going to practice some more graphs. But this time, when you look at these two functions on questions 5 and 6, they're not in slope-intercept form any longer. I have to actually rewrite it in slope-intercept form. So we get that extra practice yet again. How do we rewrite terms over to the other side so we can get it to say y equals all by itself? So I'm going to take this function for question 5 here, and I have 2x plus 3y is less than or equal to 6. And I want it to say y something. I want y all by itself. That is my end goal. So I look at the function and I say, well, if I want y all by itself, I need to move that 2x. The only way to move a 2x completely to the other side is to either add it or subtract it. So in this case, I'm going to subtract a 2x to both sides because the original x was positive. Make sure you do it to both sides. However, we cannot combine 6 and -2 together. They are not like terms. -2 has an x, 6 does not. So I have to keep them separate from one another. I draw my line, and now I'm going to work down. Well, now I just have 3y all by itself. It's still less than or equal to. Don't just randomly swap that out or change it in any way. It's still less than or equal to. And when I get to the other side, I'm going to put my -2x term first. And the reason I'm putting it first is so that I can keep it in that mx plus b form. Notice your mx comes first, so we want that x term to be first. Well, I'm almost there. I almost have y all by itself. So to get rid of that 3, I need to divide. And the great thing about dividing that 3 now is we now have y is less than or equal to, keep that slope as a fraction, -2 over 3x. And then 6 divided by 3 gives us a nice 2. This was your quiz a little while ago. Make sure we know how to move those terms around so we can get it in a slope-intercept form. That will help you greatly on your final. And now that I have this information, I can label my two pieces. My slope is -2/3, and my b is 2. Well, if my b is 2, that tells me I'm using the coordinate 0, 2. And my slope, since that negative is with my 2, tells me I'm going to go down this time and to the right 3. So start at 0, 2, down 2, right 3. Down 2, right 3. Again, make sure you can fit as many points as possible. And when we go to make our line, this time, because we have an equal sign, we want to draw a solid line. So connect your dots with a solid line. And once we have that solid line, we have to determine, well, is it everything above the line or is it everything below the line? And so we look. It says it's less than or equal to 6. All right. Take a look. If it's less than, is it going to be above the line or below the line? It will be below. So we can shade everything below that line. And we are done. Go ahead and try question 6 on your own. Practice, practice, practice. Make sure we know how to move terms around and get y all by itself. So go ahead and get a head start on question 6. Pause this video and see where it takes you. So we have the function -3x plus 5. Y is greater than 15. I want to first start by adding 3x to both sides. And that's going to leave me with 5y is greater than 3x plus 15. Divide everything by 5. And that will leave me with y is greater than 3 divided by 5x plus 3. Once I know that information, I can label my slope and I can label my b, giving me the coordinate 0, 3, and my slope's going to tell me to go up 3, right 5. Or I can also go down 3, left 5. Ask yourself, double check, solid or dashed line this time. Don't forget that little detail, it does matter. I am going to have a dashed line. So when I connect the dots, I'm going to use dashes. And then when I go to shade, it's asking for everything greater than 15. So I want to shade everything above. And I'm all done. So that was section 4.4, all right, where we're just graphing one linear inequality. Section 4.5 is going to be the same idea, but instead of just graphing one, we are going to graph two inequalities. So we're going to just take it one at a time, just like you guys did in 4.1 when you graphed two lines. Again, they were lines, so we didn't have to worry about dashes or solids. This time we have to graph two inequality lines. So they can be solid, it can be dashed. And we also have to remember to shade. All right. This time, though, when we talk about the shading, let's just do it a little bit differently so we can keep it cleaner on our papers so we don't lose track of what's happening. All right. So to get started, take a look at question 1. Again, let's work on one at a time. So I'm going to say y is less than x minus 1. Compare, make sure it's in y equals mx plus b form. And for this function, my m is going to be 1 and my b is -1. At the same time, if you're looking at that same function, why don't you look and see if it's going to be solid or dashed? Just so that you don't forget. This one will be dashed. So So all this information is what I need to keep in mind when I go to make my picture. So b is -1, I can plot that. My slope is 1 over 1, which tells me I need to go up 1, right 1. And when I connect all of my dots this time, I want to have a dashed line. And after the dashed line, I need to ask myself, well, is it solid? Or excuse me, is it shaded below the line or above the line? And this time it's telling me everything less than that function. So it's going to be everything below. Now, I'm not going to go in and shade it like this, because what could happen is you're going to shade it with your pencil and you're going to lose all those coordinates and you won't be able to see them any longer. So in order to keep things nice and neat, I'm just going to draw an arrow that's going to remind myself that on this line, I'm going to shade everything below it. So on the corners, I'm just going to draw those little arrows that tell me I'm shading everything below it. Because I still have a whole nother function that I have to graph, and I don't want to lose track and make my graph all messed up. So we'll go one at a time, we'll shade after. For the second piece, do the same thing. Label my M. And my B is going to be 4. At the same time, see if it's a dashed or solid line. This one will be dashed again. And my slope is the fraction -2 over 1. So I can plot 0, 4 first. And then my slope's going to tell me to go down to right 1. One line at a time. Don't worry about the other line that we've already graphed. We're now focused on this second one. All right, so the first line I have in blue, the second line I have up there in green. And now I ask myself, well, am I shading everything above the green line this time or everything below the green line? Look back at that inequality. That inequality said greater than, so I'm going to want to shade everything above. So I'm going to mark this one with the arrows. And now I have to compare the arrows, and we're looking for where they overlap. Whenever we have two inequalities, we have to see where they overlap each other, and that's going to be the final answer. That's what I need to see shaded. So, if I take a look at the arrows, I know that this blue line is shading everything below, and the green line is shading everything above. But the only places in which they're going to overlap is going to be in this area right here. So that's the shaded area that I want to see on your papers. At the end of all of this, that is what's your final answer. Because that entire shaded area works for both inequalities, not just one, not just the other, but both. That is what is important here. We talk about inequalities that are working for both functions that we gave you. So with that shaded, there's a second part to this, and it says, would 2, 5 be included? So with this shaded area, let's take 2, 5, and let's find that on the graph. 2 on my x, 5 on my y. So it's asking me about this point right here. And if I asked you if it was included, I'm essentially asking, is it in the shaded area? And the shaded area for both functions. And since that point, 2, 5 is not in the shaded area, we would say no. That is not part of my answer. Okay, always check to see, make sure we can understand. Shaded area means it's working for both functions. If I were to plug any one of these values in on any of these coordinates into either one of those functions I was given, they would work and make my statement true every single time. There is no question about it. In question 2, take a look at our two functions. Negative 6x plus 4y is greater than or equal to 12. That again is not in slope-intercept form. We need to know how to convert. That is the most important. So I'm going to take that function and I'm going to start by rearranging the terms, just like we did previously. Add a 6x this time because it's already negative. We get a 4y is greater than or equal to 6x plus 12. Divide by 4. And I can get the fraction simplified to give me 3 over 2x plus 3. And now I can graph this information. So my slope is 3 over 2. My b is 3. And I know I'm going to have a solid line. So let's get going. First function, 0, 3. My slope is going to tell me I'm going to go up 3, right 2, or I can also go down 3, left 2, to keep that pattern going. And when I connect the dots, it's going to be a solid line. Once I have the line, I'm going to check for where it is going to get shaded. Well, if I look back at the original equation, it's telling me it needs to be everything greater than or equal to. So I'm going to want to shade everything above that line. So I'm going to mark it so that I have an easier and cleaner grid to work with. And I'm going to do the same thing with the second function. The second function is really nice because it's already in slope-intercept form. So I don't have to rearrange anything for this. So my b is -1. My slope is going to tell me I need to go down 1 and right 1 as well. So down 1, right 1. Continue the pattern. And when I connect the dots, remind yourself, is it going to be solid or is it going to be dashed? And we know it is going to be dashed. So when I connect these dots this time, it will be dashed. And it asks for everything less than the function, so it's going to be everything below the line. And I can go in and shade. Take a look at which parts are going to be overlapping, and you will notice that it's just this section here. And that'll be the only section I need to shade. And now we can ask that second part. Would -3, 2 be included? So take a look at your graph, go and find -3, 2, and it's going to be right here. Now, yes, it falls on a line, and it's very close to the shaded area. But remember what the dashed versus the solid lines stand for. Dashed lines means it's everything not included on the line. That's why it's dashed. It's never going to be included on that line. It's never going to make that equation true. It's always going to be false. If it were on a solid line, however, yes, it would come out true because it would still be equal to that function. So with -3, 2 being on the dashed line, we would still say no. And the reason for that is because it is on the dashed line. If it were on the solid line, that would not be a problem. But in this case, it is only on the dashed line. So we're going to finish up on the last two questions. Again, these are the ones that are given to you. This is something that you might actually see on your final more often than not because your final is multiple choice. So they might give you a graph and ask you for the functions of that graph. So we want to do some things first. We always want to find the slope, find the intercept, and since we're dealing with shading, we need to make sure we're working with the inequality and whether or not it's a solid or dashed line. So if you ever see a graph, either on your test in a couple weeks or on your final, automatically start looking for the slope and start looking for the intercept. That will help you determine the functions that you're working with. All right. So I'm going to work with this blue function on question 3 first, that dashed line. There is a difference between one and the other. So the fact that it's dashed, let's mark that it's dashed just to remind ourselves that dashed lines are either going to be less than or greater than. Those are my only options. On that same line, let's look for our slope. What is our rise over run? And we can use this 0, 0 since it touches nicely. And we can use that 1, -2 as well because it touches nicely. All right, don't work with decimals. There's no use in guessing if it does cross a coordinate very nicely, so use the coordinates. And we know that on that rise over run, we're talking about -2. We went down 2, and to the right, 1. So my slope is going to be -2 over 1. And when I look for that intercept of that same equation, well, my intercept crossed through the origin, so my y value is only 0. So I go and I make my function. So I'm going to say y is something to -2x plus 0. Again, if we know it's 0, we don't have to write it as my b. And I have to figure out, well, it's a dashed line, so it's either less than or greater than. But this time it was everything above that line. So do I want a less than if it's above, or do I want a greater than if it's an above? And I'm going to want a greater than. Now that only takes care of one function. I still have to take care of this red line down below. So we're going to do the same procedure. Mark off whether it's dashed or solid. So this time it's a solid line. My only options are less than or equal to and greater than or equal to. And let's go and find the same two things, my slope and my intercept. Well, our slope this time is going to still be here. And let's go up, not to that other little point there. Let's go a little bit past it because it's not crossing perfectly at that point. It's going a little bit further. So my slope is up 1, right 2, and they're both positives. So my slope is looking to be 1/2, and my intercept, my b, is going to be at -4. If I know that information, I can then make my functions. And the only thing I'm missing is whether or not it's a less than or equal to or a greater than or equal to. And on that line, it's everything below, so it's going to be a less than or equal to symbol. And that's all I need. I just need those two functions. So go ahead and try the last question, question 4. Pause this video, practice, practice, practice. This is the most likely scenario of a question that you will have on your final here in December. So practice finding your slopes, determining if it's an equal sign or no equal sign, solid or dashed, and find your intercepts. My M here on this one is going to be, remember to always use coordinates that work. So don't just assume a coordinate, always use ones that mark in the corners of the squares. This one's going to be 3/1 with an intercept at 2. So for the first equation, I'm going to have y is something to 3x plus 2. And it's everything, actually, let's see, this time, it's everything above the line, yes, because it is technically above, so we are going to want greater than or equal to, right? And remember, if you struggle with this, check one of the values. If I want to test that coordinate that's in the shaded area, I want it to come out true. So if I tested y is 2 and 3 is -2, when I go to simplify, this is going to become 2 is something to -6 plus 2, which is -4. Well, the only way to make that statement true is to tell myself, well, 2 is greater than -4. Therefore, I can also determine what symbol is going to be in between. So you can always test points. It's a little bit more work, yes, but you can always test. So there's my first function. The second function, again, is solid. So my only options are less than or equal to, greater than or equal to. My slope this time is actually a +1. You're still going up 1, right 1. That one actually works out really nice. And my b this time is -2. So my function is y is something to 1x, or just x, minus 2. Well, that something is going to be everything less than or below that line, but I, of course, need that equal to as well. And there's our practice. Okay, lots and lots of information on these two sets of notes. Make sure you're practicing your homeworks. If you see two equations on any of your problems on the homework, make sure you're reminding yourself to do the shading after so that you don't lose track of it and you can still see your graph in the meantime. All right? Always check for solid or dashed lines. Don't forget to do that. That is part of the work. We are looking for that on your grades. And always make sure we know